coming to the aromatic aldehydes and ketones. So let me draw the structure of aromatic, what you can say, aldehydes and ketones. So this is the structure. You see it. Look at the board. This is carbon. This is your alkyl group, and this is double bond O. Fine. Now definitely oxygen will pull the electrons towards itself. You know that oxygen is more electronegative. It's going to pull the electrons towards itself. Now listen. Here, this particular one, benzene ring. Alright. It is showing plus R effect. Plus R. Due to which this pair of electron goes to this particular carbonyl carbon. Due to plus R effect. R means what? Resonance. This particular pair of electron goes to this carbonyl carbon. Hence, what you find here, that is the electropositive character of the carbonyl carbon decreases. Due to plus R effect, the electropositive character of the carbonyl carbon decreases. Alright. So you have read it, all these things, resonance and all these things you have studied. Just once more I am doing it and showing to you. So here it is C, it is R, and it's single bond O. Alright, and it is becoming double bond here. So this is positive and this particular one is negative. And here due to deficiency it becomes positive. Alright, again it goes on. The structure will go on. Alright, you know that how the structure goes on, the resonance it goes on. How it is so? That is this particular one from here, this will come here. Clear? This will be coming here, this here. Of course, in this particular position, I can say that. If you don't understand, I can say to this position, it comes. Clear? And hence the positive charge will come here. Okay, the positive charge is going to come here. In this way, it goes on the resonance. I am not going to show you the resonance effect. Already, just I told you this particular one. It in this way it will go on. Then this will come here, and it goes on. The resonance effect. So what you find is that due to plus R effect, listen carefully. The positive electropositive character of the carbonyl carbon is, what you can say, decreasing. See, it is donating electrons to this particular bond, and the electropositive character of the carbonyl carbon decreases. Now, you can say me here, that is minus I effect also, because benzene ring is minus I effect. Done. Correct. Benzene ring undergoes minus I effect. Aryl group, minus I effect. Electron withdrawing group. But here, listen carefully. The plus R effect predominates over minus I effect. Plus R effect is more stronger here than minus I effect. So it predominates over minus I effect. Due to which, ultimately, what happens is that the strength of the carbonyl carbon, electropositive character of the carbonyl carbon, you can say that, or strength of the carbonyl carbon, we can say decreases. Alright? Of course, benzene ring undergoes minus I effect. It's an electron withdrawing group. It's not an electron donor group. It's an electron withdrawing group. Agreed. That is going to withdraw electrons. But here, when plus R effect is there and minus I effect is there, then plus R effect will predominate over minus I effect because it's stronger than minus I effect. Due to which, as plus R is stronger, due to which what you will find is that the strength of the carbonyl carbon or the electropositive character of the carbonyl carbon decreases. So aromatic aldehydes and ketones are less reactive in nature. We can say that. Compared to aliphatic aldehydes and ketones. Aromatic aldehydes and ketones are also less reactive in nature due to plus R effect. Fine. Now, next is among aromatic aldehydes and ketones, we are having this particular compound, isn't it? We can have this compound like C double bond OH. This is nothing but benzaldehyde. We can say that. Clear? We can have there is alkyl aryl ketones. We can have it, of course, here. Alkyl aryl ketones like COCH3 we are having. This is known as alkyl aryl ketones. We can have also 2 aryl group also we can have it. That is diaryl ketones we can say. I don't have the space, I am drawing a small one. I hope you understand this. We are having 2 aryl groups. So diaryl ketones. We are having here alkyl aryl ketones, we are having alkyl ketones. Alright, we are having here aldehydes, ketones I am saying. We are having aldehydes here, we are having alkyl aryl ketones, and we are having diaryl ketones. So which is more reactive here? Definitely this is more reactive here. Why? Because H atom is there. Here CH3 group is there. CH3 group is electron donor group. Same thing. CH3 group is electron donor group. Electron donor group, what it will do? It will decrease the electropositive character of the carbonyl carbon, due to which the reactivity decreases. Now what about here? Here what we find is that the plus R effect predominates over minus I effect. Plus R effect predominates over the minus I effect. This is a bulky group also. It's a bulky group also, this particular one. This two group, aryl group, bulky group, due to which the reactivity decreases. So hence I can say benzaldehyde, this is your acetophenone and this is your benzophenone. So benzaldehyde is more reactive than what you can say acetophenone, which is further more reactive than benzophenone. In this way reactivity decreases. Alright, in case of aromatic aldehydes and ketones also, we can say that. Fine. Now next, so all this in general we have seen it, the mechanisms and all these things we have learnt it. Now we will see some reactions. We will see some reactions of the aldehydes and ketones, we will see it. Now look here, that is we are having CH3CHO. See, always I am writing in this way. By doing so what it happens, I remember it is sp2 hybridized, it is trigonal, planar and all those things. I remember it. So always try to write the reaction in this way, and it's easy also. Alright, now NaHSO3. What will happen here? That is, you know that this is positive and this is negative. Alright, here NaHSO3, what you find, Na is positive and HSO3 is negative, isn't it? So, in this way the reaction is going to take place. So, what will happen here? CH3, that is CH, here O is going to react with, that is nothing but, what is that? Na. And here it is carbon is going to react with HSO3. Fine. That is ONA and HSO3 it is going to be. But here you see, listen carefully here. That is this particular group. Here we are having, that is two options here. Either oxygen can react with sodium or oxygen can react with hydrogen. Now tell me, oxygen will go with this which particular group? With sodium and hydrogen. Because here sodium is also electropositive, hydrogen is also electropositive. Done. Alright, but first the reaction is going to take place in this way only, because O is going to react with Na and C is going to react with HSO3. Positive, negative, this positive, negative. Done. But after the reaction has taken place, now oxygen is having two, what you can say, attacks. From sodium also the attack will be there, hydrogen also attack will be there. So which attack will be more stable? Think of which is more stable? Hydrogen, because it's a smaller group. The bond will be smaller. Bond is smaller means smaller is the bond, stronger is the bond. Alright, and oxygen is more readily attacked by hydrogen atom. So hence, after that the rearrangement is going to take place, and due to that what will happen? CH3, CH, here it will be OH, and here it is SO3, Na, and you have seen it also. Just now I have showed you the mechanism where you are having the oxygen, that is hydrogen goes with oxygen. Hydrogen goes with oxygen. Alright, hydrogen goes with oxygen. You have seen it in the mechanism. So in this way, it will be attacked, no doubt, in this way. It will be attacked by the sodium and HSO3. But what you find is that when they come closer, then it is this hydrogen also attacks this oxygen, sodium also attacks this oxygen. So which will be more stable? Definitely hydrogen. Why? Because hydrogen is a smaller group, smaller atom. Bond is smaller, bond is stronger, more stable. We can say that. So hence, and ultimately I will say you that this product is also formed and this product is also formed. But this is a minor product and this is a major product. You will be getting it, so to say, practically. This is around 5 to 10% and this is around 90 to 95% will be getting it. So which we will consider? Definitely this one. So in this way. So this reaction takes place. Now what is the name of this compound? This is acetaldehyde sodium bisulfate. We can say that. Got it? Acetaldehyde sodium bisulfate. We got it. This particular compound. So bisulfite, not bisulfate, bisulfite. Acetaldehyde sodium bisulfite. Now next is this reaction also can take place with acetone. Here CH3 group will be there. So if CH3 group will be there, then what will happen? See here. Acetone. This is acetone now. What will happen? Just I have to put here CH3. That's it. Finished. Same thing. This is acetone sodium bisulfite. We got it in this way. So this is the first reaction you understood. Done. Now next is after that when it reacts with hydrogen cyanide, HCN, we can say that. when it reacts with HCN. Now see here, CH3 CHO plus HCN. What will happen? Okay, we have already studied CH3CH, it is OH and it is Cn. Alright, we got it. So what is the name of this compound? Acetaldehyde cyanohydrine. Acetaldehyde cyanohydrine. If you take acetone here, CH3 group, then what will happen here? Here also CH3. Then you will get what? Acetone cyanohydrine. Acetaldehyde cyanohydrine, or we can say acetone cyanohydrine, we will be getting it. Fine. Now see, cyanohydrine group is highly reactive group. This particular group is a highly reactive group. It forms several compounds. It forms several compounds when it undergoes hydrolysis, when it undergoes reduction. It forms several compounds. We can say that it is a highly reactive group. Got it? Fine. So let us see what it happens. See here, CH3CH. Here it is, what is that? OH, and here it is Cn. So first it undergoes hydrolysis. H2O/H+. First it undergoes hydrolysis. So when it undergoes hydrolysis, what is going to happen here is that you will be getting, there is nothing but CH3, here it will be H, here it will be OH, and here the Cn will be converted into COOH. Alright, this is being converted into COH. Now you might be thinking where that nitrogen goes. Where that nitrogen goes? The nitrogen is being converted into what you can say ammonia. And what is this compound known as? Lactic acid. This is called as, it is known as lactic acid. You have studied in optical isomerism, if you remember it. It is lactic acid. Now, this particular, here, if you heat it, this reaction, if you are going to heat it further, then what is going to happen? Understood? What is happening here? This is taking place in acidic medium, this one, and it forms lactic acid. And where this nitrogen goes? Cn. Got it? Now, remember it, here the reaction takes place in two steps. I have done it in one step. Listen carefully, all of you. Reaction takes place in two steps. In the first step, Cn reacts with water and H+ ion to form CONH2, amides. Alright, that is called as incomplete hydrolysis. In the second step, CONH2 further reacts with water and H+ ion to form COOH, which is known as complete hydrolysis. So here complete hydrolysis has taken place. Again I repeat. You might be thinking how we got COH, where that's nitrogen goes and where it goes, I don't understand. Okay, I am explaining you. Cn in the first step, H2 and H+, see here, H2 and H+, what it forms? Here it is, you will be getting CONH2, amides, you will be getting, amides. Alright, that is called as incomplete hydrolysis. Incomplete, that is known as. Now, in the second step, got it, 2H2 and H+ ion, what is going to form? Amides will be further hydrolyzed to form acid. Alright, and where the nitrogen will go? What I said you, nitrogen will form ammonia, and ammonia will react with H+ ion, H+, let it be sulfuric acid. Let us say, because generally H+ ion means sulfuric acid to form ammonium sulfate. That's a secondary product. I am not concerned with that. Understood? Now, fine. Now next is what I said, if you further heated this one, if you heat it, this particular one, the heating is being done. So when heating is being done, what will happen, you know, CH2H, so this H and OH will be removed. When you will heat it further, this HOH will be removed, and hence what is the product we will be getting it? Here it will be CH2. Definitely how HOH will be removed? This carries negative charge, and this will give you double bond. Because this will become positive H+, and this carries negative charge to form OH minus, H+, OH minus forms water. So hence we get a double bond here. So CH2 double bond, CH single bond, COOH. You will be getting in this way, minus water. Clear? So in this way you will be getting this particular one. So what is this compound is known as? It is known as allylic acid. It is called as allylic, or we can also say acrylic acid also we can call it as. Alright, that is acrylic acid, or we can say allylic acid, you will be getting in this particular manner. Fine. So this is the reaction, you got it, with cyanohydrine. One reaction I said. Now next, another reactions. When it reacts with ammonia, what is going to happen? See it. CH3, here it is CH, it is OH and Cn. When it reacts with ammonia, ammonia we generally write in this way, H and H2. So what you will be getting here? CH3, CH, here it will be NH2, and here it will be Cn. Got it? Now you might be thinking where that OH group has gone. This OH reacts with H to form water. It is being removed. Now what we will do is that we will go for complete hydrolysis. We will go for complete hydrolysis. Complete hydrolysis means 2H2O slash H plus. Just now I said. What will happen? It will CH3. This is CH. This is NH2 and Cn will be converted into COOH. What is this known as? Alanine. What is alanine? It is an amino acids. It is called as alanine. A-L-A-N-I-N-E. The name of this compound is. I don't have a space here. A-L-A-N-I-N-E. Alanine. Got it? Which is nothing but it's an amino acids. So we are synthesizing amino acids from aldehydes and ketones. We can say that. We are synthesizing. Got it? Clear? And this particular reaction is called as Strecker synthesis. S-T-R-E-C-K-E-R apostrophe S. Strecker's synthesis. We can say that. Clear? The production of amino acids, or we can say Strecker synthesis. Now next, after that, that is acetaldehyde cyanohydride. We can say what is going to happen. So here one more reaction is left, CH3, then CH, it is OH and Cn, we can say that. Got it? It undergoes reduction, H2 slash Ni, we can say, and heat it. Or you can also take LiAlH4, a reducing agent, which will give you nascent hydrogen. Either you can take H2 slash Ni and heat it, because this is a stronger reducing agent, mind it. Compared to LiAlH4, H2 slash Ni is a stronger reducing agent, stronger. So I have taken that. You can also take LiAlH4. So here you will be taking 4 nascent hydrogen in that case. So what will happen here? That is CH3, it will be CH, here it will be OH, and here it will be CH2 and H2. See, 4 hydrogen, here 2 hydrogen, and here 2 hydrogen is being added. So in this way, we got CH3, CH. So it is nothing but, you name it this one. So here will be nothing but we'll be starting from here. 1, 2, 3. We can say that 1, 2, 3. 3 carbon atoms is there. So when 3 carbon atom is there, then we will start from here, this particular group. We can say that. Clear? Because if you start from here also to second carbon, here also if you start, it is second carbon. So it is nothing but 1 amino propan 2 all. See, first position amino, 1 amino propan 2 all, we can say that. Clear? In this way we can name the particular compound, we can say that. Fine. So this we got it with acetaldehyde cyanohydrine, the reactions which you got it. Fine. Now next we will see the reaction with Grignard reagent. Already we have seen it in alcohol chapter. You have studied when formaldehyde reacts with the Grignard reagent, it gives you what? It is nothing but it will give you ethyl alcohol. Got it? Formaldehyde. When acetaldehyde reacts with the Grignard reagent, it will give you what? Secondary alcohol. Propan 2 all. Got it? Grignard reagent means here I will take CH3 MgBr. Let us see. When acetaldehyde, CH3CHO, you go and see in alcohol chapter, we have done it. CH3CHO when react with CH3 MgBr, it will give you what is that? Propan 2 all. And when ketone, that is acetone, CH3COCH3, when reacts with CH3 MgBr, it will give you nothing but tertiary butyl alcohol. So we got it 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. In the preparation of 1 degree, 2 degree and 3 degree, this reaction we have done it. So again I repeat, when formaldehyde reacts with CH3 MgBr, got it, it gives you ethanol 1 degree. When acetaldehyde reacts with CH3 MgBr, it gives you 2 degree alcohol, that is propan 2 all. When acetone reacts with CH3 MgBr, it gives you 3 degree alcohol, that is known as tertiary alcohol or tertiary butyl alcohol, we can say that. Clear? So we have done it this particular. Now next is we will see when aldehyde CH3CHO reacts with C2H5OH. Alright? When reacts with C2H5OH, what is happening? What will happen here? Alright? So here you see we'll take dry HCl gas. Dry HCl gas, I'll take it. Now what is the function of dry HCl gas? It will absorb moisture, water. It is going to absorb moisture. For that reason I have taken dry HCl gas. So this also acts as a dehydrating agent. It removes water. Alright, so hence what I am going to get it? See here, I am going to get the product CH3 CH, here it is OH and OC2H5. Now you might be thinking where the water is removed. In the first case it is not removed, it undergoes addition reaction. It undergoes addition reactions, you can say that. O, it goes with H and OC2H5. Now you see the second step. Second step, again C2H5, OH and dry HCl gas. Again you see, what is going to happen? That is CH3, here it is CH, here it is OC2H5 and here also OC2H5. Now you can see water is removed. Now you can see water is removed. Here OH and this H. See here, OH and this H. OHH, what is that? Water is removed here. So minus water. Clear? And OC2H5 is being added in place of OH because this OC2H5 is already here. Just you have to see this H and this OH is removed. So what is remaining? OC2H5 is being added here. So hence, what is the name of this compound? This is called as hemiacetal. Hemi, half. Alright, hemiacetal. Alright, and this is called as acetal. We can say that. Hemiacetal, and this is known as acetal, so to say. Hemiacetal or acetal, I should say that. Now this again it will react with water. This will again react with water. This particular one in presence of acidic medium to give you acetaldehyde and ethyl alcohol. Very simple. Because this is a reversible reaction. Sorry, I forgot to write it here. This is reversible. This is reversible reaction. This is a reversible reaction, you can see. So hence, this particular compound, when it reacts with water and H plus ion, it is again going to form acetaldehyde and ethyl alcohol. You will be getting it in same way. You will be getting it. Clear? But one thing, remember it. This reaction is not being given by ketones. Ketones has got no reaction with monohydric alcohols. This is monohydric, na? Monohydric alcohols. It has got no reaction with monohydric alcohols. Ketones has got no reactions. Okay. Thank you very much. In the next step we will see